The topic of my today's seminar is value of ABC water sites in Singapore public housing market. And this is in partnership with Said Iftikhar, James Fogarty within Water Sensitive CCRC, and Just Brugman from National University of Singapore. So this is kind of follow-up on one of our projects in Singapore, where we try to evaluate ABC water program. And I'll tell what it is later. So Singapore is a tropical island, but slightly different. So it is densely populated city-state, and it has abundant rainfall, and it has still scarce water resources. Because it's very small and very densely populated, it has lack of, because of island, okay, there is no aquifers and natural lakes, and small land to collect rainwater, so they actually import water from, they have artificial aquifers or reservoirs, and also import water from neighboring countries. So this is how densely it is populated, how big it is and how densely populated. In relation to some Australian cities, anyone recognize which ones is which? So, Perth, Melbourne, Sydney, and Hobart. So it's bigger than, population is bigger than Sydney, and size is, I don't know, 10 times smaller than Sydney. And it's bigger, even smaller even than Hobart, and population is maybe 10 times, 20 times bigger than Hobart. Actually, Hobart, I understand that it's one of the least dense populated cities in Australia. So it's very populated. Majority of housing stock in Singapore is built by government agency called HDB, and 80% of the population live in this high-rise building built by HDB, but they are privately owned. And another 14% live in, or 15, in privately built, also high-rise buildings, condominiums, and then 5% that are landed properties like houses in Perth, most housing in Australian cities. So this is precipitation. It's tropical island, so it's huge precipitation, still water problems. And problems with water is that floods are an issue, and they build a lot of canals and drains. So they built some reservoirs and a lot of canals to get rid, actually, of this issue of floods. I just learned yesterday, preparing to this lecture or presentation. So ABC Water Program was launched in 2006. So basically, they want to promote active, beautiful, and clean water. So they want to improve usual things like drainage and rainfall, cleaning of water, but also promote community and recreational spaces, aesthetically pleasing landscapes, and make people be more active around the water. So this program consists of a number of things, and so there is a certification program to certify developments which satisfy some of the water sensitive technologies, and also they have big projects. So there are 30 big projects out of 100 planned. 30 is being done or completed, such as canals, reservoirs, big public projects, and they spend $140 million on these 30 projects. Example, okay, so this ABC water programs, if you look at this scheme of transition of city from very primitive to highly water sensitive stage of development of city with respect to water, which designed by Rebecca Brown, which is like center of ABC, CRC water sensitive city, I guess, project. You can say this ABC water program intend to move Singapore from drained city to water sensitive city. So these are some of the sites, or those 30 sites which have been completed within ABC water centers, waters program. There are 30 sites.
Reservoir enhancement mean? Only small sums.
It is like there was reservoir, and then you can have some recreational places, some walks, some wetlands. So we can classify these 30 projects into roughly 4 types. One is standing, like I guess separately, this Bishang Park, which is like living stream. There was some concrete canal, and they converted it to stream, and also built a big park around. It is completely separate and different. There is 15 projects are canal upgrading, so there is like concrete drain, but they try to make it more nice with some benches and some greenery and some places for recreation and some people doing some activities. And also there are reservoir enhancement, same thing around reservoirs. And there are other projects like rain gardens, and there is new canal. This one is new canal, but it's different than canal upgrading. Okay? So it's interesting to see. So they spend this money. Okay, so and then what is a canal upgrading is, there are 2 examples. One is Alexandria Canal. It was canal. They built something which is nicely looking and allow different types of recreation. Another canal. What we want to know is, does this implementing of those projects, which are big public projects, to improve or enhance existing waterways or other things in Singapore, does it have value? And are those value captured by the residents? And like on the answering this question, we want to look how far this amenity extend from the project site, and also what are the potentially can ask what the distribution of the benefits. And then once we know what is the value captured by the resident, we can also ask whether this benefit outweigh cost of the project. So there were some studies on valuing rivers, streams, canals, improvement of canals, or improvement of river, or restoration of rivers. So I found, okay, we are specifically interested in the studies which are in urban settings, and those which use revealed preference method. There are a lot of studies on value of river restoration. There was a special issue in Water Management and Economics journal, but most of them were, I guess there was a review paper and a lot of studies using stated preference methods and not in urban settings. So there was one study which we did here about drain restoration. It's not really canal, but drain. And there was a number of studies which did valuation of canal using hedonic pricing methods. But we didn't find anything which was valuation of improvement of canals in urban settings. Any questions so far?
Have there been any valuation studies of canals in cities like Venice?
Yes, just valuation of canals.
Yeah, and in Amsterdam? Those are the 2 cities I think of with lots of where canals are.
I know, okay, so for example, okay, Amsterdam. There was something in, I'm not sure Venice, but something in Italy. There was a study in Italy, I forgot which one. And there was something in Texas, Austin, Texas, there is canal. And
there's more canals in Birmingham than there are in Venice.
Yes, there was a study in England. I guess the first one was.
Also, I think if you look at Manchester, there's been loads of work around the canals in terms of improving those, and that's all through urban.
But okay, so I mean, there was to improve canals, but probably not to value this improvement. There was value of a canal being close, facing canal, but not what is the impact of improving, making it aesthetically more pleasant.
Are you focusing on?
I'm interested in renewal or restoration of canals, of urban waterways. Another thing is that all the choice experiment studies, as James tells, they suggest the value about equivalent of carton of beer. And I guess in hedonics you can have higher. You can find that value would be much, much higher.
Yeah.
What?
The inflection can eat away the magical number.
Which I'll think you can find wonderful cartons of beer for just $2.
Wonderful.
So what we use in this study is hedonics pricing method, and we use log-log functional form. Actually, we have just one continuous variable, so okay, log-log, and other dummies. And we try to use difference in difference approach. So you try. The good thing about this one study is that there is high-rise and there are apartment buildings, and we can utilize this very well, which is it could be problematic in like in places like Perth, for example, unless you will find repeated sales. So what we do is we have this ABC water project influence measure, which is distance, and we don't know how, at this point of my talk, we don't know how far this impact extends, so we'll try to figure this out. And also post-construction dummy, so if everything which is after construction of this project. And also we use spatial and temporal fixed effects. So okay, so in this map you see this different colored polygons, and they are planning areas. And also this HDB, I guess, agency, they also have so-called HDB towns, which are towns, kind of, and each more or less within this planning area, and they're different. They have something common. All the buildings within this HDB town are different. So we use this interaction of planning area and year quarter dummy to try to capture if the price dynamics in each of the town will be slightly different. And also we use HDB block, which is apartment building, as a fixed effects. So this make us, I guess, we don't need to have too much details about the apartment, because all the apartments within one building would be very similar, unless they are like 2 rooms and 3 rooms. And also all the spatial or locational characteristics would be also same, exactly the same. So we use this building fixed effects to control for things which we are not interested in. So we have very few variables. We would have type of apartment, which is how many rooms, not bedrooms, but rooms they count. And what is a floor? And they have 3 kind of gradations, 3 floor, 1 to 3, 4 to 6, and so on. And we have square meters, and then we have these dummies. And whether it was before, after, and how far it is from the project. So this is this difference in difference approach with other variables. So this would be within distance of certain distance. We decide which one from the project. This is our variable. This would be after construction, after completion of the project, and this is a variable which I'm interested in. This is interaction of distance and after construction. That's what we are interested in. So so these are, we can actually estimate, but we are not interested. And we are interested in impact of being within a certain distance and after the project. And then we have this characteristic of apartments, which will be square meters, number of rooms, and story. And then we have year quarter planning area and fixed effect, and we have block fixed effect and some error.
Sorry, so that A variable is that a binary?
Yes.
Before
So
and after? It's not
yes.
like a time amount.
No. Okay, so this is binary variable,
Okay.
and we also have time.
Okay. And
But thing is that.
captured in that one.
But thing is that because we have this time quarter and planning area fixed effects, and we have actually block fixed effects, and I know it doesn't move. Block means that it will be either in or out. So we actually don't need these. These become we can estimate them, but they would be redundant. Some of these would be redundant. So basically, we can get rid of.
Is that like a fourth of the year? Is that
Yes.
Oh, okay.
We can do months, but okay. Okay, so this is actually an equation which we try to estimate. Because we don't need those two variables which I mentioned. Okay. Any questions so far? So we got this data from public sources. They publish. They don't put names of people, and they don't put apartment number, but they have like floor, three floors, address, IGB town, square meters, how many rooms, type of apartment, and price, and months of transaction. So we have this many transactions in so many blocks from 2000 to 2017, and try to do just, okay, this is where they are located. And try to do brute force kind of estimation first. So within after ABC, nearest ABC construction, and within 500 meters, we just guessed that 500 meters would be a reasonable number. And then log square meter, flat type, story, three levels. Water planning, area fixed effects, IGB block fixed effects, number of observations, R square, quite high. Because we capture a lot specifically in IGB block fixed effects. And in story also there is substantial increase, and it's consistent that increases with the height. The price increases, they go up. So it suggests it's about 2.3% increase as a result of our.
What's the variable?
It's log of price.
Oh, yeah, sure.
Okay? But, okay, we could be wrong because it's.
Did you test different distances?
Okay, let's get into it a little bit later. So the problem with this is that, okay, we actually capture all like location-specific things. So we don't need to worry about roads or whatever close to the park, unless something changes. Like, for example, they build MRT, which is a metro line, or they actually have system of improvement of these buildings and by towns, or maybe there is more smaller apartments sold earlier years and less and more bigger apartments sold in later years. So things could, I guess, we could impose relationship for some types of apartments to other types of apartments and observe this as increase due to whatever we try to measure. And there could be spatial interaction effects, but it's not important in this case. So I suspect we have something like this. So we have something, and we caught something big. It's very significant. But it might be not what we want to know. Okay. So we try to select some smaller sample. First of all, we think that we could easily measure. So our guess of impact would be like 500 meters. Maybe it's 1 kilometer, but we need to have both control where we have this project and some reference. And within 2 kilometers, we have enough reference. Another thing that this AGB towns or planning areas, they are about 2 kilometer size. So if I have like year and quarter interacted with planning areas, then some of them would be completely useless. Just increase your P value. And then also to get rid of potential impact of like building of metro lines and parks and stuff, other things which are not relevant, let's take fewer transactions for each of the project 3 years before and 3 years after to measure impact. Okay, and in addition to that, so select those buildings or AGB blocks which has transaction before and after within 3 years. And also have some matching. which is not just sale, some sale before and after, but sale of same type of apartment on the same floor level before and after. Some, not necessarily 1-to-1, but have some, at least one, of the floor 0 to 1 to 3, 3-room apartment before and after. Okay, we reduce our sample to 21,000 in 2,263 block or building. Okay, and basically studies show that if you do just regression hedonics and then you reduce to some smaller sums using matching, your magnitude would be less, because you reduce some bias, because you could have some of the variables in the sample which doesn't support your like treated observations. For example, you would, in some cases, you don't have treated sales on in very high price ranges, very big houses, and these very high or expensive houses would influence your impact. Okay, so that's what we have. We have smaller sample. So we have got rid of those HDB, or those buildings which are far away, which don't matter. Okay, so, and then how do we find distance? Instead of this A or D variable, we have a set of dummies, which is 100-meter bands from 0 to 1, 100 to 200, until 900 to 1,000, and we have from 1,000 to 2,000 as a reference. Actually, we did it all the way to 2,000, but then you don't know what is the level, because like you can and this shows that something from 0 to maybe 700 is significantly different from like those which are from 1,000 to 2,000, and from 700 to 1,000 are probably not significant. And it's not clear whether it's like 600 or 700. And this is, I don't know why. Okay, and then the guess was something like 800 we try, 700 and 600 meters. And also we could try to see if these 7 dummies would be also meaningful. And in addition, I also try what if you would construct a variable which would have distance from where 700 would be 0 or 600 would be 0, for example, and this would be 1. So you can assume that there is diminishing impact. Slope. So there are several estimates with 500, 600, 700, 800. What is the estimator coefficient? What is the error? They're significant all, but what is the AAC and BAC? And then also with the slope, like from 600 would be 0, 0 meters would be 1, and this variable instead of dummy. And 800 would be 0, 0 would be 1, this variable instead of dummy, and 7 bands 100 meter wide. And obviously there are many, there will be 7 variables, but it shows that either 600 or 700 meters is optimal distance. And like neither slope, there is no clear diminishing kind of impact, and also if you split into 7 bands, you get less fit, worse fit than with 1. And it's likely that what you observe here is just like chance. There is no reason to think that 200 to 300 meter impact would be less than these two. Okay, so we have about 1.5% the value of impact. Obviously, we can calculate precisely, but it's about 1.5%. Okay, so now let's assume that it's 700 meters. Actually, I don't know what you'll talk to James, whether it takes 6 or 7, or since I didn't have some, like maybe vote. So within this distance, there are 93,000 flats. This is not our sample, it's just like from the database, how much do they have and how many flats is in each building. And value would be, okay, somehow $2, $43 billion of these apartments. And with our improvement, we have, like with 95% coefficient interval, from 1.1 to 1.9%. And total benefit would be $660 million, and range from $500 million to $800 million. And you know that I told before that they spend $140 million on these projects. So definitely, if you look at this analysis, this is, okay, worth doing. So that's how much people captured in their apartments, and that's how much government spent. So even if you took like lower band of confidence interval, still it's worth doing this improvement.
Do they have the equivalent of land tax, Maksym?
This is, it's not, I don't think they pay a land tax. This is kind of leasehold. So they own it, like they own a kind of own apartment, but it's 99 years lease. Okay. So let's see if actually this makes sense. If it's not by chance what we observed. Okay. So we do some falsification test. So we selected same sample, similar sample to what in the actual like 20,000 observation. I took 3 years before. Let's say that our ABC project happened 3 years before. And from that date or months, I took 3 years after and 3 years before, which is like from 6 years before to 3 years before, that would be before project. From 3 years before to 0, that would be after project. And try to estimate similar model with 700 meters, just like we found that 700 to 600 makes sense. And what we get is our estimate is 0. Isn't it nice? And it slightly more observations because of actually some of the projects were completed in 2016, so it was not 3 years observation. If you go 3 years back, you get like more observations after. Okay, so we kind of think that really what we observe impact is because of ABC projects, not because of something else. Okay? Any questions so far? Okay, so now let's see. I mentioned there are these different types of apartments. I'm not sure why I put 4, maybe it's 5. Anyway, so let's try to estimate separate models for different types of apartments. So I just put one variable, this ABC times ABC, after ABC within 700 meters. And for two-room apartment, impact is minus 2%, but it's not completely not significant. And there are quite few, or much fewer observations, only 400 observations for of these two-room apartments in whole sample. And R square is quite high. 3-room apartments, 0.04%, approximately. Non-significant, I know, well, non-significant. 4-room apartments, about 8% significant. 5-room apartments, I'm not sure why. I think this is wrong. It should be bigger. And executive, so-called, I'm not sure what is that, but have highest impact. Okay, and then let's see, try to estimate.
Can we interpret the coefficients as a percentage increase?
Approximately. You take the exponential of this -1, you get very close for these small values. It would be a percentage. Slightly bigger number.
So those numbers overall look smaller than the 1.5% you were getting.
Except the executive one.
Yeah, but if you
Yes.
combine them,
Yes, it would be smaller.
numbers of them, it looks like less
Yes.
than 1.5.
Yes. So this is, I know, one of the reasons, possibly because of you have this. So these could be inflating what you observe here. Anyway, we'll still try to investigate what's going on. So this is, I try to estimate benefit by flat type. So again, this is actually percentage calculated from that coefficient, actual percentage. So we have -2, which we don't disregard. We have 0.3, 0.7, 0.8, 2.4. And these are average value of the flat in 2016. And there is benefit per flat, so negative and non-significant are removed. This is, still doesn't matter. This is number of flats and this total value. So we have much lower value. But still, the value is much higher than we have the cost of these projects. Any questions?
But it's actually lower than the lower bound we found before.
Yes.
But it is odd, because you'd have thought the combined one should just be an average across the whole lot, and the executive
Yes.
can lift it, but there's hardly any of them.
No, yeah, but on the constraints, on those adding up, it's on the parameters, not the weighted parameters. So when you think about these 0 and 1s and what the adding up constraint on dummy variables is, it actually doesn't pick. It's possible. This result is possible because they're not sort of weighted when you.
So, for example, dummies for year quarter dummy could
the same model but just for the subset of the data?
yes, it's separately for subsets.
And exactly the same model?
Exactly same model for except this variable, which is dummy for flat type, is not there because kind of. So, thing is that, for example, two-room apartments, I looked like the range of floors is much lower than bigger apartments. Okay. And those very few apartments, which are two-room apartments in full model, would have been influenced by the coefficient for apartment and floor upward. Actually, if I would estimate this model, the original model, we're just putting this interaction of this ABC times within 700 meters with this variable, I would have really big negative values here, much bigger, and very high positive here. And obviously, you can interact every variable with a flat type, which is the same as estimating separate models. So this is an interesting question. We'll try to kind of see what's going on, why is it going to. But this actually suggests that what are the pitfalls, so to say, of having variables and when you don't know what is a functional form, and when you don't know what is all the interaction and effect in a model. If you put many variables, especially if you're not, here's a dummy, if you would put continuous variable, you would have much, potentially worse outcome bias. Okay, and then also we looked at what is the, so we don't know obviously what is the income of people, their names and stuff, who buy those apartments. Okay, but we know some statistics from the census. What is the average income of people who live in two-room apartments, three-room, and so on. So these are numbers. So green line is monthly income of people who live in two-room apartments, three-room apartments, and so on. And this would be the value per flat due to this ABC project. So interesting demand for this improvement, or willingness to pay for improvement. So most benefits, at least benefit which people actually capture, would be in 5-room and executive apartments, and not much or almost not in 3- and 2-room apartments.
Could be because of if you look at
Income, yeah, people just.
Yeah, but the crossover there is going from 5 to executive. It's the executive so-called could have a function of status. People using these to show others.
Maybe.
Very much. Whatever.
So they value more. But other thing is that, for status,
wealth display.
this is possibly not the case because they also have this condominiums. That would be a status, in private sector, which are more expensive and also. So apartments, if you're not citizen, you cannot buy apparently, but condominium is not a problem, and they are more expensive, higher quality, and I'm not sure whether there is any status value of this one. Okay, and finally, we estimated this benefit of canal upgrading within ABC Water's program, and our benefit in either case is substantially higher than the cost they spent on this program. And the cost-dependent program, it's not just canal, but everything else. And we only estimated value of canals. And this evaluation could be important to promoting these types of projects. Limitations that we only captured part of the benefits. And also, like if there are canals which there is no residential housing, we cannot apply this. And in this specific case, again, we only focused on canals, and we didn't focus on something else. For example, this big park potentially could have huge benefit, and it was expensive, and it potentially has huge benefit, but we didn't include that into this model because of some issues which we couldn't explain, possibly with construction of the MRT line. Okay, thank you.